I am Chang Yong-sung with a metric number of 74378. Today, I will demonstrate an analysis of both atomic species balance and extents of reaction methods for question 1D in this assignment 2. In this assignment, it states that 100 mole of effluent gas is taken as a basis of calculation and it is assigned to calculate the amount of the reactor feed by using atomic species balance method. Before atomic species balance method is used, I will have to draw a label flow chart for this entire reactive system so that it is easy for me to do degree of freedom analysis. In order to find the number of degrees of freedom by using this method, it is required to determine the number of unknown label variables, independent atomic species balances, molecular balances of independent non-reactive species, and other equations relating unknown variables that can be found from the flowchart. In this degree of freedom analysis, there are three unknown label variables which consist of number of mole of ethylene, number of mole of water, and number of mole of inert gas. There are two independent atomic species balances which involve carbon and oxygen atomic balances. Only one molecular balance on independent non-reactive species, which is referred to the inert gas, and there are no other equations relating unknown variables as stated before. This results in no degrees of freedom after subtracting the two independent atomic species balances and one molecular balance on one independent non-reactive species from the three unknown label variables. Therefore, these unknown label variables can be solved. After that, the atomic species balance involving carbon and oxygen and molecular balance involving inert gas can be performed. Since the atomic species can neither be generated nor consumed in chemical reactions, therefore the atomic species balances take the form in a way that input is equal to the output. So, for the carbon balance, the input is unknown number of mole of ethylene is multiplied by 2 mole of carbon in 1 mole of ethylene, while the output is the summation of the number of mole of carbon in each compound containing carbon atom, which can be produced by multiplying their respective mole fraction by 100 mole and number of mole of carbon atoms present in 1 mole of each compound. Then, the calculated number of mole of ethylene is 42.3 mole. Next, same way is used to perform oxygen atomic balance. The input is unknown number of mole of water is multiplied by 1 mole of oxygen in 1 mole of water, while the output is the summation of the number of mole of oxygen in each compound containing oxygen atom, which can be produced by multiplying their respective mole fraction by 100 mole and number of mole of oxygen atoms present in 1 mole of each compound. Then, the number of mole of water is calculated and its value is 51.3 mole. Okay, next. For the molecular balance on inert gas, it also takes the form in a way that input is equal to output. This is because inert gas does not involve in chemical reaction, so there are no consumption and generation of inert gas. Thus, the number of mole of inert gas can be found by multiplying its mole fraction by 100 mole of effluent gas, and it is 11.3 mole. Next, the other method, which is extents of reaction method, is used to solve the same problem. Okay, in this method, its degree of freedom analysis is different from the degree of freedom analysis in atomic species balance method. In order to find the number of degrees of freedom, it is required to determine the number of unknown label variables, independent reactions, independent reactive species, independent non-reactive species, and other equations relating unknown variables from the flowchart drawn. From this degree of freedom analysis, there are three unknown label variables, which are the number of moles of ethylene, water, and inert gas. There are two independent reactions, 4 independent reactive species that involve ethylene, water, ethanol, and diethyl ether, and 1 independent non-reactive species that involve inert gas. And no other equations relating unknown variables can be made. And after that, this results in no degrees of freedom after subtracting 4 independent reactive species and 1 independent non-reactive species from the addition of 3 unknown label variables and 2 independent reactions. These unknown label variables thus can be solved. And by applying the equation of extent of reaction for the reactive and non-reactive species involved in this process, okay, 5 equations in 5 unknowns, which are extent of reaction for balanced chemical reaction 1, extent of reaction for balanced chemical reaction 2, number of mole of ethylene, water, and inert gas are produced. In order to determine the number of mole of the reactive species that are fed to the reactor, it is needed to find both extents of reaction for balanced chemical reaction 1 and balanced chemical reaction 2. As shown here, the calculated value of the extent of the reaction for balanced chemical reaction 1 is 4.9 mole, while that of the extent of reaction for balanced chemical reaction 2 is 0.2 mole. Then, these two values are used to find the number of mole of ethylene and water fed into the reactor. The calculated values of number of mole of ethylene is 42.3 mole, while that of number of mole of water is 51.3 mole. The number of mole of inert gas is also calculated using the equation, and its value is 11.3 mole. It can be concluded that both atomic species balance and extent of reaction methods generate the same values of number of moles of reactor feed. Therefore, the result is valid.